Hi chemists, my name is Kim and today we are going to be looking at a electroplating diagram and thinking about what is happening in an electroplating setup. So specifically we're going to take a look at an electroplating diagram and we are going to identify the direction the electrons are moving through the system, the half reaction involved on each side of this electrolytic cell, where reduction is occurring and where oxidation is occurring, the cathode and the anode. And finally, we're just going to think about why this is actually happening, why it's possible to take a metal and plate it onto another metal using a solution, right? It's going to be an interesting thing to think about. So we'll use a simulation once we're done annotating the diagram to give us a visual sense of how things are moving throughout this process. Let's go. So let's say we have a fork made of some metal. It actually doesn't really matter what the fork is made out of. And we would like to cover or electroplate that fork with a thin layer of silver metal. Now, silver is expensive, so we don't want to have to use the silver to make an entire fork. Plus, pure silver is really soft, and so it would actually make a pretty terrible fork. So we just want to put a thin layer of silver on the outside of this metal fork. So I could set up the fork in a electroplating setup. If you take a look at the screen, this is screenshotted from a simulation that I will link to in the video, but I would like you to try to think about the diagram and look at the way the batteries are hooked up and consider how we think the electrons are moving. So my hint to you is to look at the way the batteries are connected. Think about which direction the electrons are moving based on the batteries. Take about 5 seconds, pause the video if you want a little bit longer to think. So if we remember the rule that opposite charges attract and like charges repel, notice I have a positive end of the battery, my positive battery terminal, is facing this side, the side where the silver metal is. That's going to be the side that is attracting electrons into the battery because that's the positive terminal of the battery. So this tells me that electrons are flowing up out of the silver and into the battery. And then the electrons would be traveling through the batteries. And on the other end of the batteries, we see a negative terminal. That negative charge will push the electrons out because negative charges repel. And we will end up with the electrons moving the other way. So if we take a look here, right, the electrons are moving into the battery with at the positive end and out of the battery at the negative end. So the flow of electrons would be as it is labeled here, right, moving out of the silver and down into the fork. So the electrons are moving into the thing that we are trying to electroplate the silver onto. Next question is, what are the half reactions that are occurring at both sides of this electroplating setup? So I see an Ag plus, I see electrons, and I see Ag solid. That might give us a bit of an idea here. This is a tricky one, but I want you to pause the video and see if you can think about the two half reactions that are occurring. One at the silver on the left-hand side, one over at the fork on the right-hand side. So on the left-hand side, at the solid silver, I have solid silver having the electrons pulled out of it by the battery. Now, silver only has one oxidation state, so it's probably going to form an ion with a charge of +1. According to the periodic table, that's really the only ion charge it forms. So over here on the left-hand side where solid silver is, it seems like I have solid silver becoming an Ag1+ ion. And remember, charged ions can dissolve into the solution, whereas the solid atoms cannot. So I have solid silver becoming a silver 1+ ion, dissolved in solution, aqueous, +1 electron. On the other side of the reaction, I have the opposite occurring. I have a silver ion approaching the fork and reuniting with an electron from the battery that's being pushed down into the fork. The positive ion and the negative electron will attract, and we will end up with solid silver coating the outside of the fork. Next question, where is reduction occurring? On which side, the solid metal side or the fork side, and where is oxidation occurring? So we've got our half reactions written. On the left-hand side, we have a silver atom becoming a silver ion +1 electron. On the fork side, we have a silver ion +1 electron becoming a silver atom. And remember, oil rig. This is a great Mnemonic to remember, oxidation is losing, reduction is gaining electrons. So that should give you a little hint there as you think about this. So over on the side where the silver metal, solid metal is, that's going to be oxidation. The silver atom is losing an electron, oil losing an electron, to become a silver ion. Over here on the right-hand side is going to be reduction. That's where the silver ion is gaining an electron to become the neutral silver atom. Final question to think about, where is the anode in this setup, and where is the cathode? Where is the anode and where is the cathode? As a reminder, you can also use a handy memory trick for this one. Red cat, reduction happens at the cathode always, anox. The anode is where oxidation happened. So remember, red cat and anox. So if we go back here, the anode is where oxidation is occurring. So that's going to be the silver metal side. The cathode is going to be the fork side. And here we can see it happening in motion. And let's sort of imagine for ourselves what that fork might look like as silver begins to pile up on it. So I've got silver becoming a solid on the outside of the metal fork as the silver continues to electroplate on, right? So as long as this electroplating battery is running, this reaction will continue until silver atoms have coated the outside of the fork. And then we have a fork that is electroplated in silver. You'd only know that it wasn't if you scraped off the electroplated layer. Let's check back in on our learning goals. Hopefully we feel more comfortable looking at an electroplating diagram and thinking about how electrons are flowing through the electrolytic cell, the half reactions that are involved on each side of the cell, right? The idea that the metal is becoming an ion on the side where we're dissolving the metal into solution. So the metal that we are trying to electroplate onto the other metal, in this example, silver, is where oxidation is occurring. And then on the other side of the cell where we're taking the metal ion from the solution and we're making it solid onto whatever we're trying to plate it with, that's where reduction is occurring. I challenge you to take a look at your silverware and jewelry. You now probably have a pretty good idea of how it was electroplated. Awesome job today.